Time for us to do a little broadcast domain busting here with some virtual LANs. But even though that's a huge reason to create VLANs, breaking up that broadcast domain, making smaller domains, limiting the scope of the broadcast, there are other reasons to do so as well. And a big one is that VLANs help us group hosts by department, by security clearance levels, by color of their hair, lack of same in my case, any criteria you could think of, rather than being limited to geographic location. Now, VLANs are also kind of thought of as a security feature because they help you increase security by hiding a logical group of hosts away from everyone else if you so desire. And we could do that with regular VLANs. We have some advanced features of VLANs you'll run into in other studies called private VLANs. So it does help us hide hosts away from the rest of the world if that's what we want to do. But the big reason that we're interested in VLANs today is to help prevent network performance degradation by limiting the scope of the network's broadcasts, a term you're already tired of, but I'll try to limit it from now on. And that in turn prevents a broadcast storm. Now, a broadcast storm is not a sudden event. It doesn't happen out of nowhere, where your network is just humming along and then all of a sudden, wham, all your switches are at 100% performance or 100% CPU load because they're getting hit with so many broadcasts. It's gradual. And what happens is, you may notice some slowdowns and there's no explicit reason why that you've spotted. And then you'll have people start going, network's a little slow in the morning, the usual thing. And let's be realistic here. As much as we love our end users, it's easy to tune them out once in a while when we get a generic complaint, as I call it. Like, well, it seems slow. How slow? Well, slow. But the thing is with the broadcast storm is that slowly the number of overall broadcasts the switch is having to handle increases because broadcasts tend to beget more broadcasts. And as you add more hosts and you keep them all in one VLAN, you've got even more broadcasts going on. And when the storm, so to speak, hits, at that point, due to the sheer number of broadcasts in your network, the switch is so busy handling those that it can't carry out its basic functions like forwarding our unicast frames and our multicast frames. It can't do so efficiently. And like with most bad things in life, it's better to avoid such a storm in the first place and do something about it in advance than worry about recovering from one when it hits. Now, a quick note here, we're going to do a live lab here. And I'm going to assign an IP address to each of our hosts. I've actually already done that, and we're going to do some configs and some testing here. Now, IP addresses run at layer 3, and we haven't configured them yet, but we have plenty of that coming. And if this is new to you, if you don't even know what the /24 in the next diagram is, no worries, because you will. I have to move forward a little bit here with IP addressing because without them, it's really hard to run these tests. And here are the 4 hosts that we've got connected to our switch right now. I am using Cisco routers for hosts, so the pings are going to look a little different than they would if I did them on an actual PC, but the intent is the same and the return is really close. I'll be glad to show you a PC ping later on so you can compare the two. You likely know what one of those looks like, but if you don't, we'll fix that. Now, the switch connections over there, host 1's connected to fast Ethernet 0/1, host 2 to 2, and so forth. That's what I like to do in my labs, keeps it nice and orderly. And they are all in the same subnet, and they can all ping each other. I did test that before we started. I didn't want you to have to watch all those pings, but by golly, here they are. And these are the pings I sent from host 1. And I even pinged host 1 itself. But here I pinged host 2 successfully. Right below that, host 3 successfully, and right below that, almost, host 4 successfully. So I was able to ping actually from all of them. I'm not going to show you all those pings because they all look the same. But this is what we have, and the connectivity is indeed all there. So what we want to do now, we want to do a little verification though, because I did make these drawings, but people make mistakes, and sometimes you go to a client and the network map is a little bit of a mess, or maybe what you're seeing doesn't quite sync to the switch connection, say, that you're shown on the right-hand side of the screen. So I also want to just get you in the habit of verifying before you start either a lab in your home lab or working at a client site, because it only takes a few seconds to verify what you're seeing. And if you're also being told, oh, by the way, all these hosts are in the default VLAN, well, you better check that out too. Because if you dive into a lab or dive into a config and they're not in the same VLAN, then you're going to have some trouble. You'll end up with a bunch of unnecessary troubleshooting. So I know you have to watch, hurting the client's feelings or anything like that. But if the client catches you verifying something that he or she said and they get mad about it, just blame me. It's okay. First thing I would do is absolutely make sure my physical connections are what I think they are, and show CDP neighbor is great for that. And right now we're on host 1, so we just see switch 1, which is what we'd expect to see. Where I want to verify is over on the switch, because that's going to show me all of my connections. And you can see here's a whole list of devices. It's actually going to show you the host name, which is great. And the local interfaces do match up, 1 to 1, 2 to 2, 3 to 3, and so forth. Host 5 is also there. We're not going to use host 5 right now. We're going to give that device the lab off. So what else can we verify here? How about that VLAN membership? Let's do a show VLAN. I want to show you show VLAN and then show VLAN brief, because I showed you show VLAN brief earlier, I believe. But if you have not seen this before, this is what show VLAN gives you. And the information, frankly, that you need to get started is right here, and with the VLANs that you create. These other 4 default VLANs, and I would know those numbers, you are rarely, if ever, going to use those. And I'm not saying you'll never use the information down here under that, but it's pretty specialized. You could go a long time without using that info, and it's not something we're going to get into in this course. Show VLAN brief just gives you that information at the top. And I know you've got a couple of ports off there because it does hit the side of the screen. Excuse me. But all of our ports are in VLAN 1 by default, as we expect. So everything's been verified. We have verified connectivity to the switch. We ran show VLAN brief, and we're good. You may notice something else about VLAN 1. We know it's the default VLAN, but it is so default. It is so default that it is even named default. And like I said, you got these 4 other VLANs down here. These are all default VLANs, but 1002 through 1005, very rarely are you going to use those, because they're for technologies that either we don't use often, or thankfully in the case of Token Ring, I'm really glad they're not around anymore. Enough of that. Now we're going to create some other VLANs, because every individual VLAN that we create, we know it now it's its own individual broadcast domain. So by putting a couple of devices in a separate VLAN in our lab, we're going to cut down on the number of broadcasts immediately. And let's go ahead and do that. We're going to put hosts 2 and 4 into VLAN 24. The command to do this is switch port access, and the only option from here is VLAN. And then you're either going to assign it a number or use this dynamic option. And the dynamic VLAN assignment is not part of this course, so we're just leaving that alone, period. And we're going straight to 24. Now, notice this message: access VLAN does not exist, creating VLAN 24. Well, the thing is, as it says, VLAN 24 didn't exist, and we ran show VLAN brief, and we saw the 5 default VLANs, and that was it. And so it was nice enough to create VLAN 24 for us. That doesn't happen a lot. Usually on a Cisco switch, if you try to work with something that doesn't exist yet, it's going to say something along the lines of, hey, that doesn't exist yet, you got to go create it. But in this one case, it will actually create the VLAN for you. Now I'm going to go to interface 4. That's 4, and put in the exact same command. And you'll notice it didn't give me a message about having to create it, because the last time we put a port into VLAN 24, which was about 20 seconds ago, that VLAN was created then. If you want to pre-create a VLAN or create one for any other reason, you don't want to do it this way, you can just enter VLAN in global configuration mode and follow it by the number that you want to give it. So we could create VLAN 45. There you go, and you'll notice the prompt changed to config VLAN configuration mode. We're not going to put anybody in VLAN 45, but I wanted to show you that alternate method. So let's do a show VLAN brief. And congratulations, we have created a couple of new VLANs, VLAN 24, and you can see it's active. and it's also going to show you the ports. And the reason that I'm doing that line right there is that when this screen gets crowded, and it will, you could run show VLAN brief and your entire screen is going to be full of VLANs, VLAN numbers and VLAN names. And you're going to have ports all over the right-hand side. I strongly recommend that you do just what I did when you're looking at one. Let's say this whole screen was full of VLANs and I want to see what ports were in VLAN 24. I would go just like that because the bar is showing you which ports are in VLAN 24. It's really easy, especially when the screen is filled with VLANs, for your eyes to go up a row or down a row. This will save you some unnecessary troubleshooting. It's a great little trick. So we also have VLAN 45, and VLAN 45 is empty. But we expect that because we just created it. We didn't put any ports into it. So everything we're seeing here is perfectly fine. And what we've done now is this logical segmentation. Hosts 1 and 3 are still in the default VLAN, VLAN 1. Hosts 2 and 4 are both in VLAN 24, the non-default VLAN that we just created. Now, we're going to talk about the impact on the network as far as broadcasts go with this, and also do some testing to see if we have any other issues pop up, and that's coming up next.